we're ready to get started. Welcome everyone to the 4th AATF Technology Thursday webinar. Today we have another cutting edge presentation from VEGA, giving us insights into how VEGA expands its product range to cover specific measurement technology for food and beverage, pharmaceutical, and water waste industries. So today our presenters are Clint Viviers, Tyron Azevedo, and Miguel Peterson. I'd like to give you a bit more information on these presenters. Clint has experience in multiple industries such as mining, petrochemical, power generation, food and beverage, and the chemical industries with a good knowledge of related processes as well as process control principles. Clint qualified in 1991 in instrumentation with Instruments Trade Test. He then joined SAB for 5 years, and after that, Clint joined VEGA Controls in 2001. Tyron has been with VEGA for more than 10 years now. He's currently responsible for business development in the water and wastewater industry and EPC business. He has been involved in multiple industries during his time in VEGA, from mining to petrochemical and food and beverage. Miguel Peterson is based in Johannesburg and has been with VEGA for the past 7 years. His time at VEGA has seen him engage in various roles within the business, allowing a holistic understanding. So as you can see at the bottom of your screen, there is a question and answer facility. Please feel free to use that throughout the presentation, and we will have a dedicated time when those questions will be answered by the team from VEGA. So without further delay, let's begin the presentation. Over to you guys.
Good day, everybody, and welcome to our presentation. As just introduced, my name is Tyron, and I'll be starting off this presentation today. What we'll be focusing on is a bit of VEGA's product expansion, specifically into the water and wastewater industry, as well as the food and pharma industries. So yeah, that's just a basic overview of what we'll be going into, and yeah, we'll spend a bit of time on the industry itself and the importance of measurements, and then we'll move into some product-specific information as well with regards to the new devices that VEGA has launched into the market. So firstly, if we look at the water industry, probably the most important resource when it comes to natural resources for pretty much every country in the world. So why do we need reliable measurement technology for the water industry? So for a couple of reasons. Firstly, one of the most important things is control and measurement in terms of usage of the water. So this allows for municipalities and governments to plan with regards to the farming industry, etc. So this is one avenue that requires very accurate level measurement. And the other one is for process-related plants. So in our sewage farms, etc., where we will be actually clarifying water and creating clean water for drinkable use. Obviously, it's very important to have good, reliable measurement there to keep the processes running efficiently. So if we look a little bit at VEGA and our experience, so VEGA's been around for about 60 years now in the level and pressure measurement game. And over these years, we've installed approximately 500,000 devices into the water industry, as well as about 50 odd different types of applications within the water and wastewater industry. So this just gives a little bit of a brief overview of the experience that we do have in this particular industry, and why, and with this experience, how we were able to launch and bring new products into the market that is specific for this particular industry. So if we look at some typical measurement principles that we'll find within the water industry, we think of pressure transmitters. So quite simply, in applications like pipelines, airlines, etc., where we just need to measure pressure. hydrostatic pressure measurement. So this will be level measurement with the use of pressure transmitters. So typically in boreholes, reservoirs, etc. We then have radar sensor technology. So this is a non-contact type measurement used for many different types of measurements, such as open channel flow applications, dam levels, river levels. Then we have ultrasonic type sensors. This again is a non-contact type level measurement, and typically as well used in any sort of open tank environment, open level measurement environment. We then also have some display and signal conditioning instruments. This, together with our level measurements, can do things such as pump control. It does do calculations for open channel flow, or even something as simple as a remote or field mount display. And I'll speak a little bit just now about remote measurements, where we'll use some of our signal conditioning instruments to actually transmit information from very remote locations. So that's just a brief overview of the measuring principles. If we look at some of the advantages that VEGA holds within the measurement technology, we think of words like maintenance-free. Our radar devices are very good proponent of this, where we believe these devices are maintenance-free due to some of the technologies, with some of the technology in the devices that, again, we'll cover a little bit later on why there's no maintenance required on these devices. Robust, our devices, particularly if we look at pressure transmitters with ceramic cells, very robust in for industries where we're measuring sludge as a perfect example. Devices last a very long time. Reliable. Again, this talks a lot to the maintenance-free and robust. This is probably just a nice overview of the first 2 points, where our devices are reliable for the number of reasons, which we will cover again a little bit later on. Comfortable. We look at that particular picture. We have a look at our app, which is used to calibrate devices. So this allows us to calibrate the device without having to be in any uncomfortable position, as well as pull diagnostics, etc. So that is just a brief look at some of the advantages that our technology brings to the particular market. So yeah, if we just have a quick look at some of the applications that we have covered and some within the water industry. So we look at sewer overflow. So with the use of non-contact level measurement in a radar, in this case, level measurement in these particular applications. Pump stations, again, very similar with froth and foam is what we're trying to showcase here. Open channel flow with the use of a radar, as well as one of our signal conditioning instruments to actually measure the flow rate of water through these particular channels. Screens, again, level measurement within these applications. Chemical vessels, different types of chemicals. Again, we'll cover this where we talk a little bit about materials of construction and things like looking through plastic tanks, etc. And then on the more higher end type applications on the digester within a sewage farm, we look at our higher end level radars. And then, as I mentioned earlier, we do have some options with remote measurements, and this will be typically used in reservoirs that will be in remote locations, dams, river levels. We are, with some technology, able to do these measurements and transmit the signal remotely to a laptop, to a cell phone, etc. So you'll be able to control and monitor these sorts of levels from afar. And then just again, a brief look at the types of applications and industry within the water and wastewater industry. And it's at this point now that I'll just hand over to Clint. Clint will now just run through some of the actual technical details of the applications and the instruments that we will be using in these applications. Over to you, Clint.
Thank you, Taryn. So we look at different measuring technologies in various applications in different markets. There is always a question: which technology is the better one to use? And end users would always consider non-contact measurement as one of the more favorable devices. Then we got to consider, do we use radar or do we use ultrasonic levels? So historically, ultrasonic has always been the preferred non-contact level measurement device. I've looked at this picture. The applications shown here are generally quite easy. So most of them are water applications. There aren't many process conditions that will negatively affect them, but there are applications out there that negatively affect ultrasonic level due to the technology used. So a sound wave is transmitted to the application, reflects back, and there's a number of factors that affect the sound wave from the ultrasonic level transmitter. So if we look at a few of these factors that do exist in some applications, there are pressure factors, maybe pressure vessels. Sometimes processes run under vacuum. There could be certain gases and fumes present in the measurement, high temperatures, steam, wind, fog, humidity, rain. So if we look at these factors, ultrasonic technology is normally affected negatively, which might cause maintenance issues. And if we now consider radar in these applications, based on the technology used here, radar is not affected by these process factors. So here we look at the development of radar over time. So the current offering is the 80 gigahertz radar, which is a development that's progressed from years back where it started with 6 gigahertz. So with this 80 gig radar technology, the end user has more confidence in his measurement. And if we consider the more difficult applications that exist, solids applications where we have tall, narrow silos, for example, and we have a lot of dust, a lot of noise in these applications. And on the liquid side, you might have chemical industries and petrochemical, where you have high temperatures, a lot of corrosive gases present, fumes that could dampen the signals. So radar has been developed around these factors to create confidence for the end user, to have peace of mind, to reduce maintenance, to reduce call-outs for his staff. So this is the long-term goal for end users that utilize these measuring technologies. Moving over to the new product offering that VEGA has expanded on. So we now consider the water industry, for example. These are more easy applications to measure. So mostly water. There's not a lot of process factors that exist. So we don't need this high-end radar level transmitter, but it also overcomes the factors that could affect an ultrasonic level transmitter, which was always the number one choice for these measurements. So we look at this product spread. We see there's a compact version, there's a cable version, and the cable version then also connects to certain controllers where you can have different functionality like relay controlling pumps, valves. You can use it for level control and so forth. So a closer view of the compact radar level transmitter. Here we can see it's a compact device with a local display as an option. This is a particular model, the VEGAPOINT 31. Comes with a display. It's the body or the wetted parts is made of PVDF, the housing of PBT Velox plastic, which is highly UV resistant. So integrated display, as I mentioned, and this can be set up for liquids or solids measurement where we don't need the high-end devices anymore. So to further view the product options, if we look at the compact unit with the housing, we have a VEGAPULSE 11, Pulse 21, and the Pulse 31. So these are designed for suitable or specific applications where we can overcome or replace the ultrasonic technology. So, for example, the entry-level ultrasonic on the market generally has a bigger physical size as these new radars, and the 5-meter range ultrasonic was the entry level. So now we have a smaller device, a radar level, that can measure up to 8 meters, and the accuracy is also vary depending on which model you have, and it's kept simple with 4 to 20 or 4 to 20 Hz output options. So the product spread is not huge, so there's no Profibus. This is meant for the water wastewater industry. Then the cable option. So we have a compact radar with a cable, direct cable outlet, and this is also designed it's for connection directly to a PLC. It's 2-wire loop powered. It can also be connected to these controllers that we have on offer. And the potted housing is completely sealed, so we have a high IP rating on this device. So even when flooding occurs, for example, if the position of mounting is low enough where you might have an overflow situation, the device will not drown, if I may say so, and as soon as the level drops again, the device will continue functioning as normal. So the overview of the cable version radar. So the VEGAPULSE C versions. So the C is the direct cable outlet, and there we can see the different options from ranging from 8 meters to 15 meters, and there's the C23, which is a 30-meter range for liquids applications, and we have different protocol outputs on these devices, which include Modbus and SDR12, which is used more in the motor industry. So here we have our new controllers. And you can see a nice overview. It's got a waterproof housing. It's a much better design for outdoor installation where you don't need additional enclosures and covers. It's got a large graphic display, and the functionality of these controllers is optimized for the water and wastewater industry. And it's very easy to set up and commission. As Tyron showed, there's a picture of an iPad. And so all these radars and these controllers come with built-in Bluetooth capability where you can use a tablet or a smartphone to configure these devices. Okay, so overview of the controllers. We have the MET 840 series, which has a single or dual output option, and 3 control relays for pump control or alarming or valve control. And then the 86 series has a little bit a more increased functionality where we have a single or dual channel again, and we have up to 6 control relays on this. And on the 86 series, there is data logging functionality, and the controller is equipped with an SD card to save all the backups, and it's basically a trending function for remote applications where you don't have a PLC or a SCADA in place. Okay, so here's the Bluetooth functionality. So as I mentioned, we use a smartphone or a tablet, and we can connect remotely onto these devices up to a distance of 25 meters away. And we can configure. When it comes to security, each device has its own Bluetooth PIN code that has to be inputted onto the smart device before calibration and setup can be done. And now it's over to Miguel, who will speak a little bit about the food and beverage industry. Over to you, Miguel.
Thank you, Clint. We'll quickly have a look at the measurement technologies for the food and beverage, as well as the pharmaceutical industries, and just some brief insight into these industries. These are critical industries as it is essential for livelihood. Therefore, extremely high standards are required as the consequences of inefficiencies in production could have far-reaching effects on health, the population, and the economy at large. So typical products we're looking at in these industries are your beverages, liquids in the form of beverages, processed water, cleaning detergents such as your CIP and SIP. Then there are also pastes such as ice cream, yogurt, jam, honey, those types of products, as well as bulk solids in the forms of cereals, sugar, flour, powders, and similar products. In the pharmaceutical industry, you've got two types. You've got your solid pharmaceuticals, which is in the form of tablets and capsules, and then liquid pharmaceuticals, where there are mixing processes involving heterogeneous liquids such as oils and waters. And on this particular slide, we will now have a quick look at the different measuring principles that we could use within these applications. So when it comes to foodstuffs and pharmaceuticals, extreme care and hygiene is required in any kind of handling or processing. The measuring instruments used here must in no way influence the product, must be easy to clean, and have relevant approvals where necessary. In the food and pharmaceutical industries, the instruments have to deal with products in every conceivable form and physical state, and at widely varying temperatures and conditions. So if we have a look at the slide, we see here there are various measuring principles shown. We've got continuous level measurement, reliable point level detection, and pressure measurement. There is a suitable measuring principle for every different set of requirements. For example, in continuous level measurement, the sensor determines the level continuously while the container is being filled. An example of a continuous level measurement device is seen on the center tank, where you've got a non-contact radar transmitter and a contact level measuring principle in the form of a hydrostatic pressure transmitter. Different technologies are available. We've got radar in the form of non-contact or guided radar. We've got capacitive technology. We've got the hydrostatic, as I mentioned a few seconds ago, as well as differential pressure as an option as well. On the other hand, there's point level detection. In point level detection, the sensor registers when a predefined filling height is reached and sends a switching command that starts or stops filling equipment such as conveyor belts or pumps. Here there are also a few technologies available. There is the vibration, capacitive or conductive technology, and those are the basic ones we use for point level measurement. An example of point level measurement is seen on the tank on the left hand side, where we've got an instrument mounted at the top detecting a high level, and there's one at the bottom detecting a low level as well. Depending on the measuring environment, for example, temperature, strong shocks, and the medium in the form of liquids, pastes, powders, as we mentioned, different measurement techniques are used. The measuring result can be transmitted directly to a control system and used to control complex production processes. In the next slide, we will now have a look at some application examples, some real application examples where the devices have proven to be very reliable and have proven to assist in creating a fluid process for the client. We've got edible oil production, which is a typical application where you would find buildup. That means oil sticking to the face of your device, but our devices compensate for that as well. We've got a filler, which is generally small vessels requiring compact devices. We've got tanks or vessels with vessel internals, such as stirrers, heating coils, and the likes. For this, we've got signal focusing, which allows us to still have accurate level measurement. We've got spices and powders. This is usually dusty environments and products with low reflective properties. And grain silos, which are usually tall and narrow vessels requiring reliable measurement over a long range. And then we've got fryers, which is there to symbolize applications that have varying temperature requirements. So these are just some of the examples of the applications that we use, or that our instruments are used in for the food industry. We'll also have a look at some applications in the pharmaceutical industry, just very briefly. We've got the vacuum evaporator. There are the processes where granulation takes place, filtration, and then also reactor vessels. And these are all complex applications with high hygienic requirements. And the VEGA product expansion, which Clint will explain to us shortly, opens opportunities for compact devices to be used in these applications. So that is just basically some examples on the pharmaceutical industry. And then here's just an overview in terms of what the devices can handle in terms of CIP, SIP cleaning, your dust, your powders, and all the approvals that may be necessary within these industries. I'll now hand it over to Clint as we look at some of the products that I've just been referring to in my slides. Thank you, Clint.
Thanks, Miguel. Okay, so looking at the products aimed at the food and bev industry, as well as the pharmaceutical industry, we have compact pressure transmitters and switches in the range. And these devices are specifically manufactured and designed to fit the application requirements that exist within the food industry. So we have the VEGABAR series. That's the 10, 20, and 30 series. And on the slide, we can see that there's a range of compact devices that have been developed. So look on the first option, that's a fixed range pressure transmitter. It's a VEGABAR 10 series. Then we have the VEGABAR 20 series. Comes with LED light indicator, and the VEGABAR 30 series with a ring LED as well, with a local display also to indicate the pressure, and it has onboard functionality on the display to make parameter adjustments and do a complete setup of this device. Some other features built into these devices is IO Link protocol. So for the factory automation plants, this is very suitable, as IO Link is a preferred protocol to be used with high-speed updating, and it's suitable for fast applications. And these are equipped with Bluetooth as well. So the VEGABAR 20 and 30 series doesn't require the HART protocol anymore for remote connection and configuration. So all this is done by Bluetooth, where you use your smartphone or tablet to do complete configuration and setup. So on the next slide, we have the hygienic process connection indicated here. So when it comes to certifications for the food and bev industry, we comply to the FDA requirements. Full certifications are available. We have the process connection, which varies in size and options when it comes to hygienic connections. And we add the threaded type. So this is fully adaptable. So to view the comparison between these two models here, we have the ceramic option on the diaphragm seal on the right-hand side. It's oil-free, very robust and resistant to abrasion. And the metallic diaphragm, also suitable for applications where the ceramic might not be suitable, and where O-rings or polymer O-rings are not suitable for those applications. On board the pressure transmitters, as I mentioned, there's a large LED ring. So with the pressure switch functionality, these devices have the 4 to 20 output as well as transistor switching capabilities, where it can be configured purely as a pressure switch or a transmitter and a switch both in one. So this LED ring shows you the switch status depending on the configuration and at which pressure points the switching should take place. And there's a numerous array of colors that can be selected on these devices. So for example, if you have technicians in the plant, for the ladies, pink might be more suitable, and for the guys, blue might be more suitable as color options for the switching. And these LEDs are very bright, so they can be seen in very, may I say, long distances in your plant. Even where the sun is shining directly onto these devices, the LED is very visible and the status can be viewed from far off. And when it comes to failure modes, for example, you have a flashing LED indication, and this can also be detected very easily when a fault is being detected on the transmitter itself. So we look at the hygienic adaptability, the design around these devices. So as a common choice, the threaded versions are always chosen in most applications. So the design on these transmitters is now to take the threaded version and adapt it to any hygienic process connection that is required. So we can retrofit an existing installation with these devices, and a standard threaded version can be kept in stock, for example, with a range of these adapters. And the threaded version purely screws into the adapter process connection. And it ranges from the typical clamp type to very vent fitting to the dairy coupling type of process connection. So there's a full adaptability system that is being developed. Then we look at the VEGAPOINT point level switch. This is a capacitive level switch designed also for various applications, and not only in the food and bev industry. So we have the VEGAPOINT 10, 20, and 30 series. The VEGAPOINT 10 being a very simple device, adjustment-free. It's used on water-based mediums. You get the VEGAPOINT 20 series, also for liquid applications, and the VEGAPOINT 30 series for light solids applications. The VEGAPOINT 20 and 30 is equipped with Bluetooth as well, in case of adjustment requirements. So you might want to use the VEGAPOINT 21, for example, on interface measurement between oil and water. So the VEGATools app can be utilized, and simple adjustments can be made to make these devices suitable for applications besides low-level and high-level switches. So here again, we have the adaptable feature on the VEGAPOINT. So with the threaded version, we can take the hygienic adapters that are all FDA approved, and we can screw them onto the level switch. And we've converted this into a fully hygienic level switch suitable for the food and bev and the pharmaceutical industry. Okay, so again, overview, VEGAPOINT 10 series can be used up to 100 degrees Celsius, and that is continuous use. And then we look at the 20 and 30 series up to 115 degrees Celsius. And these two VEGAPOINT, the 20 and 30 series, is also equipped with IO Link for the factory automation industries. Okay, so we have reached the end of our presentation, and we just want to thank everybody for attending. And from here, we'll handle any questions that come up. and we'll be ready to answer. Between myself, Miguel, and Tyron, we'll be answering any further questions for you.
Great. Thank you so much to the VEGA team. That was really, really informative. I think it's really great to get insights into the VEGA product range expansion and the opportunity to use them. As mentioned, we will be taking some live questions. So please use the Q&A box at the bottom of your screen to submit your questions. And the team from VEGA will be answering them live. So you can start sending your questions over at this point in time. And I'm going to hand over to the VEGA team to answer your questions. Over to you guys.
Thank you, Chardonnay. Yeah, so I'll just go straight into some of the questions that have already popped up. Clint, I'll pass this one on to you first. The question is, will ultrasonic be phased out in the future? I think that'll obviously be with reference to speaking about the newer devices we've launched.
Yes, so if we look at the progress of the radar technology, the plan is to minimize maintenance issues on the plants. So the new radars, if we do a quick comparison, the physical size is obviously a lot different. So ultrasonic is bulkier and bigger. If we look at the components that are required to manufacture the ultrasonic levels, the demand is becoming less because of the radar technology. The cost of manufacturing ultrasonics are not going to be as low as what radar can be currently. So the plan is to eventually phase out ultrasonics completely. But our customers do not have to worry about not having a replacement. So obviously the process fittings will match the ultrasonics, so we can do a direct replacement and you'll have a better device at the end of the day.
Great. Then we do have a question here that says, what makes an instrument fit for hygienic use instead of a petrochemical plant? So if I can just answer that one quickly, if I understand the question correctly, is so obviously in a hygienic environment or a food environment, the requirement for hygienic process fitting is a lot higher because you don't want to have any places for dirt and so on to build up. So that would be firstly the use for hygienic fitting. And the major difference between the two is merely that. So from a threaded connection as an example, which we typically use in the petrochemical or mining industry as an example, that obviously isn't suitable for the hygienic. So in that case, if I answered the question correctly, understood it correctly, the major difference would just be the hygienic requirements in the food industry. And then Miguel, I'll pass this one on to you. What is the difference/advantages between ceramic and a metallic diaphragm? As Clint pointed out, the two different options within our new level devices.
Thank you, Tyron. The difference is that ceramic measuring cell, the ceramic measuring cell is oil-free, and so it's a dry cell measuring cell, and it measures the pressure quite reliably, as does the metallic cell. But the difference is that the ceramic cell can handle rough and abrasive medium and products that could have abrasive properties. The metallic cell doesn't perform too well on those because of the material. It's a very soft material, and so the robustness and the overload resistance of a ceramic measuring cell makes it a bit better in those types of applications. On the other hand, metallic measuring cell is a fully welded and elastomer-free cell, and it's basically a hygienic design which is optimized for cleaning, easy cleaning. But as I mentioned, the major differences there is the ceramic cell is very robust. It takes a lot to damage the ceramic cell, and that is mostly used, where they are in vacuum applications, so that the diaphragm does not get damaged by a vacuum, and also by abrasive products such as frozen vegetables or anything with abrasive properties within the process. That's the major difference between the two.
Right, and then if I can just add there, obviously a metallic diaphragm does have its applications where it is more suitable. So applications such as very high temperatures, as an example, a metallic measuring cell will be far more useful. And then Clint, I'll just ask this one to you from one of the participants. How do you ensure security with the Bluetooth configuration option of devices, as well as how do you handle interference of the other devices operating in a similar band?
Okay, so when it comes to security on the Bluetooth, every single device has its own PIN code defaulted from the factory. So this is, it comes with a little brochure in the box as it's delivered, and it is changeable, or every customer can modify it to what they prefer. So they can keep, let's call it intruders, if we want to call it that. They can keep people from logging in randomly and maybe sabotaging plants and changing parameters and so forth. And with regards to ICM band, so a lot of tests are done in the factory with these devices. So because of the operating frequencies of our devices and that, we would not interfere with any kind of ICM band whatsoever. It's totally the measuring devices operate at a totally different frequency to these ICM bands. So there's absolutely no interference whatsoever.
Great, thank you. Yeah, then another question we've got here is, what are the benefits of using the VEGAPOINT 64? So I'll just answer that one there. So the VEGAPOINT 64, as Clint mentioned on our radars earlier, operates in the 80 gigahertz bandwidth. So some of the typical advantages of operating in this with this frequency would be things like a narrow beam angle. So advantages there would be, or benefits there would be, measuring in tanks that have got a lot of interference inside the vessel, so cross beams, etc. So we're able to, with the narrow beam angle, aim the device better into, in this vessel and allow for better measurement. Because of the higher frequency, we do have a lot stronger signal, also known as a dynamic range. So what this does is, because of the higher signal strength, we're able to operate better with things like condensate, mist, steam, etc. inside of a vessel. So that I think would be the main advantage of the Pulse 64, and that just comes out of the 80 gigahertz frequency band that we operate with the Pulse 64. Then Miguel, if I can just ask you a question there. So in terms of the new point level switches, so this being the VEGAPOINTs, how do they perform in adhesive products? So I would imagine products like yogurt, etc., that might have some buildup on the actual probe itself.
Okay, the nice thing with the new point level switches is that with the setup, the Bluetooth setup on our Vega Tools app, we are able to set up and adjust the device to detect the product and almost ignore the buildup, if you want to call it that. So it's all in the setup and it performs quite excellently. We've got them working in applications such as tomato sauce. We've got them in peanut butter and similar applications which are very adhesive products and often cause buildup. So to answer the question simply, yes, they perform very well in those types of applications, and it's all done on the Vega Tools app by simply adjusting the device to tell it what is product and what is buildup.
Great. And then Clint, we have a question here as well. Can you do interface measurements with the 80 gigahertz radar easily, or do you need a high difference in dielectric constant for this to work?
Right, so when it comes to interface measurements, the non-contact radar is not suitable for such applications because we don't get the signal actually penetrating through the upper medium and detecting a secondary medium. So in other words, oil and water, for example. So the guided wave radar as a continuous level measurement device is more suitable for this because it operates at a much lower frequency. So the signal will pass easily through the top medium, which is a lower dielectric value versus water. So when it comes to non-contact radar, we do not use that for interface measurement.
Right, and then I'll just answer this question that just come in now. If you just need a level for a reservoir with a 4 to 20 milliamp output, which unit will you use? And if we just need the signal to go to a PLC or an RTU. So there are a couple options. So we would look at either one of the newer non-contact radar options, or alternatively looking at a hydrostatic level measure or hydrostatic pressure transmitter. So that would be a little, the main factors that we would look at there is just the height or the depth of the reservoir. So that would determine the selection that we have there with regards to what device. But it would, in this, with the reservoir, it would either be one of our non-contact radars or hydrostatic pressure, with the factors that I've just mentioned as what will determine on which direction that we go. And then Clint, I'll pass this one to you. Can we measure through the top of a plastic tank with our radars?
Yeah, so the beauty of radar is that if you have chemical tanks made out of plastic, you don't have to cut a hole in the top of the roof. So the radar signal can attenuate through the plastic roof of the vessel. And so we just do a little bit of fine tuning if necessary to ignore any echo that might come off the plastic roof. But the signal penetrates through the roof, and we reliably and accurately measure any liquid that is inside plastic vessels. So it's a huge benefit when it comes to chemicals, because there's a lot of fumes, maybe leakage. So you don't want holes in your vessel. So radar measures straight through the plastic wall.
Great. And then Miguel, I'll just pass this one to you. It's an IO-Link question. So the question is, should we expect more IO-Link devices in your range of instruments?
Sorry, Taryn, if you could just repeat that for me.
The question is, can we or should we expect more IO-Link devices within the range of our instruments?
Yes, from an IO-Link perspective, this is definitely just the beginning for VEGA in terms of the IO-Link integration. So I think, without saying too much, yes, we can expect some more IO-Link or integration into the IO-Link systems in the future, yes.
Yeah, so just to reiterate on that one, our current devices that have IO-Link will be all our new pressure transmitters and our new capacitance level switches. Yep. These currently have IO-Link. So yeah, so we do have those options currently available already as well. And then I'll answer this question. The question is, how can we measure open channel flow? So this measurement will be done with two of our units. So one being a non-contact radar level device, and then this will be coupled with one of our controllers that would do calculations for us. So quite simply, we would use, like as I mentioned, a non-contact device into a V-notch weir, rectangular weir, Venturi type setup. We do have all these options for calibration available on our device. So depending on what open channel we do have, you would just make those selections, and the device then is calibrated that way. And then coupled with a signal conditional controller, we are able then to basically have a totalizer function as well, where we can totalize the flow that goes through these open channel flows. So short answer, yes, it can be done, and quite simply with a level transmitter and a controller. And then one other question here with regards to the 80 gigahertz radar. What is the benefits of this radar? Clint, I know I did cover this a little bit, but I don't know if you want to maybe expand a little bit on 80 gigahertz and the advantages there.
Yeah, so when you answered the Pulse 64 question, you did cover a lot of the pointers, but if we look at additional applications, so let's take as an example. So very often we lose signal when we have foam generated on certain products or liquid products. So the dynamic range on the 80 gig radar is so high that it can still have a reliable measurement even when there is foam present. So it gives a much more reliable measurement. And if you look at overfilling, so these new radars are developed to handle flooding situations. So if a tank overflows, the medium actually touches the lens of the radar, you still have a stable measurement showing full. You won't lose echo, you won't have fault indications. so your process is still controlled reliably. So these are just some additional factors of the 80 gig radar.
Great. And then Miguel, if we wanted to just have a quick chat regarding like interface measurement, possibly with our new VEGAPOINT. So when I say interface or measurement between two different products, so you know, within a pipeline, identifying whether we have water or a lower dielectric constant product in there, or yeah, or like I say, interface in a vessel.
Yes, that is possible indeed. The VEGAPOINT is, as I mentioned earlier with build-up, it has the same functionality where we've got the a window, a setup window with device based on the decay of the product, that if you use water and oil, for example, that this is water, and then you tell the device that this is oil, and it then product. So that way you've got an interface measurement between oil and water. And also the emulsion layer, the device is able to, you know, distinguish emulsion and actual product.
Great, thanks, Miguel. Yeah, in terms of questions, yeah, there are no open questions at this stage. It seems as if there's no more. If there's anything else, please, guys, feel free. Clint, if there's anything you want to add to some of the questions or anything that you would like to mention.
So maybe as a overall statement, you know, VEGA worldwide, we are extremely excited about the new product range that has been launched. So it really gives all our personnel worldwide, it's almost like new hope that there's continuous expansion, there's continuous development. So VEGA is never standing still, if I can put it that way. There's a continuous improvement, and the demands of customers are always listened to. Flexibility is always key within our company. So we continuously expand and improve, if I can call it that, to benefit our customers at the end of the day. So it creates a fantastic relationship within the supplier, end user world, if you can say. So yeah, it's just great. It's exciting times. Although the last couple of months have been challenging, but we still look forward. We're all positive, and we really are excited.
Yeah, just to add to that, the word flexibility also comes to mind, and you know, we appreciate input from customers when it comes to that with regards to you know, the requirements of certain products. So please, you know, if some of our good customers, please talk to us. Any customers, talk to us if there's something that you feel we can't cover. You know, we believe we're flexible enough to accommodate that. Yeah, in the meantime, there has been a question that has come in. On the VEGA Pulse, how can you prevent the overflow of water inside the tank where you mix two materials into the tank, for example, water, gums, sticky material? How do you prevent the water to overflow because the level is not detected, only the water is detected? So, sorry, I see that is from Johannes Mokwena. So, Johannes, I don't seem to understand the question 100%. So what we'll do is maybe make contact with you after the webinar, and maybe we can just chat a bit more about the application. I'm not sure I understand the question there too well.
Maybe Tyron, just a guess on that one. So maybe there's a certain, like foaming, for example. So if there's a mixture, could be a chemical reaction. So if the radar only detects the water level, but there's another medium above that, so we could recommend a high-level switch as a backup to detect whatever other medium there is, and then you can interlock that and prevent an overflow situation. So I guess that would answer the question.
Yeah. Okay,
Great.
I'd just like to add one more thing from my side. In terms of Bluetooth compatibility, there may be someone sitting there with instruments that they've purchased a while ago and are now concerned, are they still able to use the Bluetooth functionality? The nice thing with any one of our Plix sensors, we've got our PlixCom with Bluetooth integration. That allows you to have a device, any Plix sensor dating back to 2002 can be made Bluetooth compatible by simply attaching a Bluetooth PlixCom onto the device. So your PAL 64s, PAL 69s, and any device that can take a VEGA PlixCom, we can attach one of those, and you can then do setup and calibration using the Bluetooth and the VEGA Tools app, as you can with our new devices. I just thought I'd add that in case there's anyone who has existing devices, Plix sensors, and who wants to use the Bluetooth functionality.
Great. Well, thanks so much to the VEGA team, and thank you to the audience as well for the very the interesting questions. I think if other people were hesitant to ask, you did answer some of their questions for them. But if, as Tyron has mentioned, if you still have questions that you need answered, please contact the VEGA team directly, or you can send it through to us at the AATF team, and we will forward it on to the VEGA team as well. So thanks again to you guys, Tyron, Clint, and Miguel. I think it was very innovative, and yes, we look forward to seeing a lot more in May at AATF at the Ticket Pro Dome from the 18th to the 20th of May. Great, so thanks again to everybody for your participation, and we look forward to seeing you at our next AATF Technology Tuesday, which will be presented to you by IDX on the 4th of August. Until then, keep warm, keep safe, and we'll see you then. Thank you.